Hi, I'm Alex Fraley. This is Data 625 Unit 6, Network Graphs. In this video, I compare two client communication networks and highlight cybersecurity risk using betweenness. In these visuals, larger and warmer colored nodes have higher betweenness, which means they act as bridge nodes. Bridge nodes sit on many shortest paths, so they can become high-impact choke points. The edges represent messaging links between nodes. First is Network 2. Network 2 is a dense mesh. It has many crosslinks and many alternate routes. Connectivity is spread out across the network. The main security risk is the high betweenness bridge nodes, especially Stealth, Spectre, and Shadow. These nodes appear larger and warmer because their betweenness is higher. Because they sit on many shortest paths, if malware reaches one of these nodes, it can move through the network more efficiently. Even with those risks, Network 2 is comparatively robust. Since there are multiple routes, if one node goes down, the network is less likely to break into isolated pieces. Messages can often take alternate paths. For Network 2, my recommendations are: monitor and patch the bridge nodes first, and reduce lateral movement using segmentation and least privilege access. Next is Network 3. Network 3 has a very different shape. It looks more like a hub and spoke, or a set of tree-like segments. In this structure, risk is concentrated into a few choke points. The biggest choke points are Nebula and Starhawk. Their betweenness values are much higher than the rest, so they act like gateways between parts of the network. If one of these nodes is compromised, malware can spread widely because so much traffic can pass through that node. Network 3 is also more fragile. If Nebula or Starhawk goes offline, parts of the network can become disconnected, and messages may not get through between segments. For Network 3, my recommendations are: add redundancy links to reduce dependence on Nebula and Starhawk, and treat these nodes as Tier 0 assets with the strongest protections like MFA and EDR, tighter segmentation, and strong backup and continuity planning. Now here is the comparison. The key difference is risk distribution versus risk concentration. In Network 2, the scatter plot and the graph show multiple moderate to high bridge nodes. Risk is distributed, so the network is more resilient to a single failure. In Network 3, the scatter plot shows two clear outliers, Nebula and Starhawk. Risk is concentrated, which makes the network more fragile and more likely to fragment if one critical node fails. Final takeaway. For Network 2, focus on targeted hardening of bridge nodes and segmentation. For Network 3, focus on topology improvements like redundancy plus locking down choke points, because the structure creates single points of failure.